Hi everyone. In this video we're going to begin to talk about Chapter 2, which is titled Data Visualizations and Numerical Summaries. At least that's what I have titled Chapter 2 as. So as an outline of what we're going to talk about in the videos about Chapter 2, we're first going to talk about the types of data. Okay, we learned what is data, sort of, in the first chapter. In this chapter we're going to get into seeing different types of data, and we'll also look at graphical summaries of data. Okay, so we'll take a good bit of time to look at graphical summaries, and in fact you're going to have a project where you explore many different kinds of graphical summaries. And then lastly we'll talk about numerical summaries of data, and you'll be very familiar with most of these, at least have seen them before. We may get a little more technical than you're used to, but we'll talk about measures of center, okay, how to tell where the center of the data is, because that's usually a question of interest. Measures of variability, how spread out are the data, because that's also of interest. Yes. And so let's start by looking at some data. So we never really looked at data in the first chapter, so this is our first taste of what data is. Okay, remember, why am I so interested in talking about data so much? Statistics is about gleaning information from data. Okay, and so we're especially interested in pieces of information. Okay, so let's start by talking about some data that has to do with irises. Okay, and so here's the data. Now, when we'll see data in this class, it'll be in many different formats, but this is the format that we'll see most often. Okay? Every column, you'll usually see it in a spreadsheet of some sort, so you might see it in Excel, you'll see it in other ways that I will show to you. But anytime that you take data or that you see data, hopefully it's in this form where every column is a different variable. Okay, so we have 5 variables here: sepal length, sepal width, petal width, and species. These are all things about irises, and I will show you a picture and tell you what sepal and petal mean. Okay, but we have 5 variables here. Some are numbers and some are not, and that's okay. They're all data. And so here's a picture of what these irises look like. Okay, the petal is the part from the very middle of the flower out to the part that that I would actually usually call a petal myself. Okay, but it's the sort of stem-ish thing from the middle to the end, and then the sepal is the end of that flower. Okay, so that's petal and sepal, and they took lengths and widths of these irises and collected this data. Okay, a variable are the characteristics that we observe when we take measurements. I used the word variable before, and I'll try to not do things like that, but it's just in my vocabulary. So when I slip, especially if we're in class, make sure to tell me. Okay, so the variable is usually taken in some type of study. So usually we're interested in a question, like I said in the first chapter, and so we take data that hopefully is going to answer that question or help to answer that question for us. So here's data. I'm interested in talking about the different types of data that we see in the sort of matrix-looking table that we see above. Okay. So I've rewritten it on the side. There are different types of variables. Okay? So the first type of variable that I want to talk about is a categorical variable. So there's categorical variable, and then the other type of variable that we'll talk about is quantitative or numerical variables. So first, sorry, I was getting ahead of myself. Talk about a categorical variable. It's a variable whose values belong to one of a set of categories. Okay? So, what does that mean? Usually, you think of a categorical variable as a value with no units associated with it. Okay. So usually people think of a categorical variable as not a number. Okay, something that doesn't have a number in it. Some examples of a categorical variable are a year classification in high school. Okay, are you a freshman, a sophomore, a junior, and senior? And some people do that for college as well. Another one that's fairly common is something like eye color. Okay, blue, green, brown, so on and so forth. Okay, but one that people usually get tripped up on is something like zip code. Okay, so the zip code in which you live in. Shippensburg zip code is 17257. Okay, where I grew up, it was 17356. Okay, and we all have a zip code associated with us some way, somehow. But is a zip code a numerical variable or a quantitative variable? And the answer is no, because there aren't any units associated with it. Okay? When we talk about quantitative or numerical variables, they are numbers, but they need units associated with them so we can tell the differences. So we can tell a difference between two values. And so what I mean by that is if I look up at the data and I look at a variable like sepal length. Okay, so it has different values, 5.1 and 4.9. In order to be a quantitative variable, it needs units associated with that. And there are, it could be centimeters probably, is what these are taken in. And there is a difference if I look at the first two irises and I subtract the two. Okay, I subtract the 2 and I get 0.2. So 5.1 minus 4.9 is 0.2. Does that difference have any meaning to you? And the answer should be yes. Okay, the first iris has a sepal length of 0.2 greater. Okay, so the first iris has a longer sepal length, and that has meaning to us. But if I subtract zip codes 17356 minus 17257, I get 101. But what does a difference of 101 in zip code mean? Okay, I don't think there actually is one, so there is no difference. So operations like addition and subtraction, multiplication, they don't have any meaning with quantitative variables. I think that's the easiest way to remember that. There aren't units associated with the value, even though the value may be a number. Okay, and not to get off on a rant, but oftentimes when people ask you a survey on a scale from 1 to 10, what do you think? Okay? Those questions are actually pretty terrible questions to ask, okay? Because unless you put units associated, put units on those questions, it's really hard to tell the difference between a 4 and a 5. Okay, you know that maybe 4 is greater than 5, but a difference of 1 has no unit associated with it, and so it's really hard to tell a difference. Okay, so if I ask people on a scale of 1 to 10, how angry are you? Okay, and you say a 6, and someone else says a 7, I know that the other person is slightly more angry, but how much more angry? Okay, and then further on, when we talk about numerical summaries, if you apply a numerical summary to this, okay, so if you apply a numerical summary to a categorical variable, that can be disastrous because there's no meaning in differences. Okay, so back to my ranting example, they'll say that the average person if I average all of those numbers together and I get an average of 4.5, that sort of tells me something, but it's dangerous to do because people are not good at distinguishing a 6 or a 7. So, like, somebody could say, "Oh, yeah, I'm a 6," okay, when really they're very angry. On their scale, a 6 is probably really angry. But there are other people who will say like 9 because they are more likely to uh, be extreme, although they're not really as angry. Okay, so sorry, something to think about. I'll stop ranting and get on with the video now. But that is an important thing, especially when you create a study. You have to be very careful about the type of question you're asking, what kind of analysis that you want to do on that data, so on and so forth, because the results could be disastrous if you do it wrong. So, back to looking at the 5 variables that we have above. Species is our only categorical variable here. Okay, there are 3 types of irises, setosa, versicolor, and virginica. And so the species is a set of categories, hence a categorical variable. So the other one, a quantitative variable, is a variable whose values are numbers. Okay, so they really need to be numbers if they're quantitative, but those numbers have units associated with them. Okay, so example, height, weight, IQ, number of states visited. There are lots of quantitative variable examples. Okay, as long as they have units with them and they are numbers, they are quantitative. Back to our example, okay, all of the other 4, because they have units associated with them and their numbers, are numerical or quantitative. Okay? We can actually dig deeper into those types of data for every type of variable, categorical or quantitative. There can actually be like subgroups to those. Okay? So for categorical variables, there's the definition again, okay? But there are different types. So the first one is an ordinal categorical variable. Okay? Observations here for ordinal variables have an order associated with them. So, for instance, back in the last slide, I gave an example of class year in high school. There is a definite order there. I know that sophomores are a year ahead of freshmen, and then juniors are above sophomores, seniors are above juniors. Okay? Conversely, eye color, which was my second example, there's no way for you to say that blue is above or better or anything other than above or better than brown or above or better than green, so on and so forth. So there's no order associated with eye color. It is a nominal categorical variable. Okay, so there's ordinal and nominal. For nominal, observations have no order associated with them. Okay, so the what I was talking about earlier with that Likert scale, so when you do a scale from like 0 to 5 or really unsatisfied to really satisfied, those scales are called Likert scales. Likert, I believe, is how you spell it. Likert scales. Those are all ordinal categorical variables. Okay, and so there's some order there, which means you can do some things. Okay, but you can't do everything that you can do with a quantitative variable. So there are 2 types of categorical variables. There are also 2 types of quantitative variables. The first type is a discrete variable. Okay? And so the discrete variable I define as that the possible values are countable. Okay? Countable. And I say usually they're integers. Right? And so if you're have taken enough calculus courses, or you're a math major, or you're mathematically inclined, there can be an infinite number of values that are countable. Okay, so if I start counting from 1, 2, 3, and then I count all the way up until I can't possibly count anymore, and that becomes infinity, that's called countably infinite. Okay, so when things are countable, then they're discrete. Okay, but what we'll usually deal with in this class are integers. Okay, and then there's a continuous variable. And how you define a continuous quantitative variable are that the possible values form an interval. Okay, form an interval. So for this instance, can you tell me how many numbers there are between 0 and 1? Okay, up to an infinite number of decimal places. So the number of unique numbers between 0 and 1, okay, the interval between 0 and 1, is uncountable. There's an uncountably infinite number there. Okay. Anything that follows that sort of description is called a continuous variable. So for the end of this video and the first your turn, I'm going to give you another data set on diamonds. Okay, this is a very popular data set to work with in the statistical and data sciencey world. Okay, that's the first time I mentioned data science, but I will mention it a lot. Okay, the diamonds data set has data on somewhere around 50 to 60,000 diamonds. All right, and for each diamond, there are a number of variables that you can talk about. So you can talk about cut. Okay, the cut of a diamond. The most ideal cut is the ideal cut diamond, and then it goes ideal, premium, very good, good, and fair. Okay. You can also talk about the color of a diamond. So usually when people think about diamonds, they think about colorless diamonds that you can see through, so on and so forth. Okay? But diamonds can range from colorless to yellow. Okay, so there's colorless to yellow. A diamond can be yellowish. Okay, then there's also the clarity. Okay, the clarity of a diamond. Okay, and this is on a sort of grading scale. The highest is flawless. Okay, but then you can go down internally flawless all the way down to what's called included. Okay, and if you're interested, you can look these up online, and they will show you pictures of each. Okay, the clarity is that those included diamonds are probably going to be pretty opaque in the middle. Okay, but a flawless diamond is probably going to be pretty clear. Right. So there's cut, color, and clarity, and then there's a bunch of other stuff. Okay, two things that you'll probably know or certainly can understand are carat, how many carats a diamond is. Certainly we know that's an important consideration. We talk about a diamond, and also the price of the diamond. Then there are a number of other numerical and I'm giving some of this away. There are a number of other numerical measurements that you can take on a diamond as well. Okay, depth and table are two examples of that. So what I want you to do is I want you to do what we did for the iris data set, but now with the diamonds data set. So I want you to identify each variable, okay, as categorical or quantitative, okay, and then tell me if it's nominal or ordinal if it's quantitative, or continuous or discrete. If it's categorical, or continuous or discrete if it's quantitative. Okay, so just label each of the 7 that I have here as categorical or quantitative, and then tell me which subgroup they're in.